Which brings us to our last presentation, which I think is Kai Andrich. And Pavel, do you also have a role in this last part as well? Yes. Yeah, you do. Okay, so yeah, Kai. Yeah. Okay, thank you, Kai.
Okay, ladies and gentlemen, yes, we will do it. And my role this time will be slightly minor one. Kai will present the main part of our presentation. Only just from my side, few words about purposes, about background, about goals, and why we are doing what we are doing. And then I will pass the floor to Kai, and he will present rather technical, let's say, elements of our two pilot investments that are implemented within the liquid energy project. Okay, so I will go through both of them, and the floor is yours. Okay, so the first one is, as I mentioned before during my first presentation. Thank you, Justin. Is a microgrid system, a grid-off system that is concepted in a manner to give an opportunity to use, to let's say, produce energy and provide energy in the areas with the lack of infrastructure. And this system is put in a shipping container, which is a standard form, standard size. And we made this kind of investment just after following the discussion with the experts, with the market, with the business, that defined the parameters, that defined some crucial elements that are important to while preparing this first pilot investment to be tested and to act as a showcase. And if you remember my previous presentation, this is one of, let's say, the last elements if you are talking about a distribution and supply chain scheme for on the micro and nano scale level distribution scheme for LNG and bio-LNG. And the second part of the presentation that will be done by Kai is to present and explain a bit more detailed form our worldwide first micro LNG bio LNG refueling station, mobile refueling station. That is a unique development, as I said, worldwide, and gains an attention of from all over the world, I have to say. And I'm personally really proud that our lead partner of the project decided to be responsible for this pilot investment. And this is one of the crucial and necessary elements if you are talking about change of paradigm in logistics, change of way of thinking about distribution, and of course change of paradigm if you are thinking about what is actually the distribution scheme for the future. Last but not least, after a presentation made by Kai, you are all warmly welcome to join us outside because the mobile refueling station is with us. It's the vehicle is parked next to the building, so everybody that is interested in more, let's say, tangible experience, if you are talking about this pilot investment, is welcome to join us. So, Kai, the floor is yours, and thank you.
Yes, thank you, Pavel. Oh, that's printed on it. Okay. Yeah, I want to start with the micro energy container. And first I start with which type of fuel cell we are using and why we are using it. Then a quick overview about the energy container, which you have already seen. And then the gas system, the heat circle, and the solar energy. And last but not least, then a summary of all the components we used. So, of course, there are more types of fuel cells, but there are only 2 types of fuel cells that work with methane as an input. And there we have the polymer electrolyte membrane fuel cells and the solid oxide fuel cells. The solid oxide fuel cells work by oxidizing the fuel, and the PEM cells work with ionizing the fuel. So 2 completely different systems. But as you can see, the SOFC has a very high, very high operating temperature, which produces some danger and some challenges, because this high temperature leads to chemical and mechanical challenges and also failures because of high temperature. Yeah, but the PEM fuel cell is designed for mobile applications, and also using a low operating temperature, which is quite favorable for our situation because it's also less risk in handling the equipment. So we decided on a Fissmann fuel cell, and yes, let's come to the overview, which you can see here. And since Fissmann is a provider for literally every part we may need, we decided to not mismatch the parts and get everything from Fissmann. So we have here the fuel cell from Fissmann. We have a gas condensing boiler from Fissmann, which gives an additional heating output. And of course, some heat storage, which in this type of situation is the heating water cylinder from Fissmann, and also a battery for the times when the solar system is working, and also for the overproduction or general production of the fuel cell. And of course, it's powered by an LNG, which is in a tank, which then goes into a vaporizer. And here we have the tank, which then goes into the vaporizer, into a gas control system, which then divides into the gas condensing boiler and the fuel cell. And as you can see through the piping, it's quite chaos. This is a multi-purpose cylinder, so we can. It has connections for the fresh water, for the heating of the fuel cell, also for the heating for the heating circuit of the gas condensing boiler. And last but not least, here on the other side is the electrical department with the battery and the electrical compartment. Yes. Now a side view for the gas side. So here we have the tank, again, the vaporizer, the gas system, which I explain in a second. And here we have the boiler and the fuel cell. And also you can see here the vent for both sides. Yeah, and there are quite some regulations for the handling of gas, which in Germany is the technical regulation for gas installations. And they declare that the gas for every gas installation needs to have special properties. In this type of environment, we need to have a gas which is around 0 degrees Celsius at least, and has a pressure of 20 to 25 millibars. And this is what this area is for. Here we come directly from the vaporizer in a pressure equalizing tank, then in a first safety valve, and from the safety valve we go into a thermally activated shut-off valve, so in case of a fire that the whole system can shut down. There's also another thermally activated shutdown valve directly on the fuel cell. Then we go into a gas filter, which we seen on one of the earlier slides, that the PEM cells are quite sensible to fuel impurities, so we need a gas filter. Then we have two pressure gauges, one in front of the pressure regulator, this is the pressure regulator, one in front of the pressure regulator and one behind it. From there we go into the second safety valve, which is set to 100 millibars, and the split goes then into a gas flow meter to actively measure how much gas is used. Yeah, and then we have a split for the gas condensing boiler and then the fuel cell. Okay, now the heat circle. It's from the back view because it's in the back of the container. Yeah, here we have the water container or the water cylinder in the middle, and from here we have all the connections which are connected to the heat circuit module, which is used for the which provides the circulation for the heating circle. So you see here the connection to the outside. So you just connect your heating circle for wherever it's needed to this connection, and you can use this part to actively pump the cold water and the hot water, to actively use the heating inside of the tank, inside of the container. There's also an hydraulic switch to control the hydraulic pressure, which are also used for these two tanks here, which also control the hydraulic pressure because water at different temperatures can have different pressures. So we need, for both systems, for the fuel cell and for the gas boiling system, we need two water equalizing pressure tanks. Yeah. And on the left side, we have the freshwater input with a filtration system. I also have a different slide. No, that was the slide I just explained, sorry. Here, with a filtration system for the incoming water. Here we have a water valve, and you see here the house connection or the general connection for water, for gas, if you need extra gas, and for the information, like an Ethernet cable for the monitoring of the whole system. And on the right side on the wall, we have the heating connections and for the hot water, which is also provided by these, where is it? This one here, the thermostatic circulation set, which can regulate the outgoing water temperature for fresh water or drinking water. Yes. Now we come to the last part. We have 4 photovoltaic modules on top of the gas container, on top of the energy container, to provide general energy and also provide energy for the starting of the fuel cell, because to start the fuel cell you need a little bit of energy. And the energy is then stored in the battery, which also stores, as you've seen in the beginning, the energy of the fuel cell which is produced. So in case you have no consumer, the energy is stored either as heat or in the battery of the container. And also you see here the 2 vents. Number 4 is actually a special vent designed by Fiesmann to be independent of the room temperature, not room temperature, of the room environment. So you actually can have different air circulation in the room than on the outside. So in case here it's inside the container, it can be dusty, it can be any type of air. It doesn't affect the fuel cell at all, because you get your air from the fuel cell from the outside, which is also number 5 is for. It's a vent for the inner room. Yeah, and here a general summary for the parts we used. So here you see the fuel cell actually has 0.71 kilowatts electrical power and 1 kilowatt thermal power. It's powered by methane. And the additional gas condensing boiler, in case you need it, provides 19 kilowatt of thermal energy. The cylinder has 950 liters of internal storage for water, so you can store quite a lot of heat. The photovoltaic modules, each module has 405 watt peak, which is in translation then 1200 watt peak for the whole system. And it's mounted modularly on top, so you can either screw it or you can weight it down with concrete blocks, however you need it. And the electrical storage is quite big with 12 kilowatt hours. It has an internal inverter, and it's a hybrid system, so it supports the input of the photovoltaic modules and the fuel cell. Yeah, and as I already explained, we have a gas control system and a vaporizer also in the system. Yeah, that was it for the gas container. Any questions?
Yes.
Just a curious technical question. This capacity of this gas container, if you attach it to a combustion engine,
Yes.
the production of electricity, what would be possible?
The fuel cell needs around 0.2 cubic meter per hour, and our tank can fill up to 450 liters of LNG, and the ratio from LNG to gas is around 1 to 600. So let's say 1 liter of LNG is 600 liters of gas. So if you would translate that, it is, what did we calculate? I think 25 days, around that.
That's a high concentrated form of energy, really.
Also, it's because you don't run the fuel cell 24/7. You mostly run it for 12 or 13 hours a day. So that also expands the capacity a lot.
Thank you.
So the first question, if I understand it correctly, other way around, is it possible to have variable parameters talking about electricity and heat? Because I understand that this microgrid produces heat and electric power. And what has to be done, or is it just fixed as it is? And then if some potential end user would like to have a certain amount of electric power, then this person or this potential end user has to take decision in the beginning, what is the, let's say, the mix of energy, heat, power that will be needed? This is the first question.
Yeah, the fuel cells are actually stackable. So in case you don't need the heat that much, you can, instead of the gas condensing boiler, just add a second fuel cell, for example. Or if you need more solar energy, you have seen we have at least space for one more solar panel on the top if you need more electricity. And if you even need more heat, you can get a bigger condensing boiler. This one we're using is more on the lower end. I think they can go up to 30 kilowatt thermal energy, at least from Fissmann. Maybe there is a different provider. Also, you can also use a different fuel cell. You don't need to use Fissmann. It's just what we decided on. For example, there are, at least in Germany, there are, for example, Buderus or Remeha, but they mostly use the SOFC cells. So that's a different kind of fuel cell type. There are also companies in Germany that produce, I think it was a 5 kilowatt electrical power fuel cell. In-house, exactly. So yeah, the components can be mixed matched. It's just that we decided against mismatching because one is testing and also it's safer that way. Because if we have a problem, we can maybe ask Fissmann and don't have to solve it ourselves.
I have a technical question. I saw that liquid gas tank is placed inside the container.
Yes.
We set our tanks on deck because Polish Register of Ship calculated that ventilating power should be up to 30% of power of the engine hour. And what is with ventilation system in your structure?
We have actually multiple ventilations on the wall. Also, in case we need even more, you can open the doors of the container. And we also provide an active ventilation system. So there will be some air ventilation inside the tank if needed. It can be, for example, in Germany you might not need that much ventilation, but if there's, like Michael said, in Nigeria, it would most probably needed an active ventilation system because of the temperature.
We said the same, but the calculation of PRS was other. Is very high power consumption calculated from ventilation, so we set on open deck our tanks.
Okay, the second question I have. So I do understand that this is what is implemented in this case. It's use of fuel cell, which means that as an input, the fuel cell gets methane as a gas.
Yes.
And burned is what?
Actually, the fuel cell converts the methane, which is CH4, into hydrogen, which is H2 at least. So in this case, LNG is the energy carrier for the hydrogen, which is then burned, or not burned directly, more ionized in the fuel cell. Which is also a reason why we use the special, or not why we, but FISMAN uses the special ventilation system, because during the process CO2 is produced. And there's some filter inside this system so that the CO2 is filtered by going through the system.
Okay, thank you.
Yes, and last for today, the mobile LNG refueling station, or mobile bio-LNG refueling station. Yeah, there I want to talk about the first concept, a little bit about the components and the advantages of the mobile refueling station. Then a quick overview about the scheme of the power system and the liquid and gas. And then I will talk about the handling of the whole system, which includes the operation of the cryogenic vessel, the refueling process, and also the measurement process. At last. Yeah, so this was the first concept of the refueling station. Here we still have only 2 tanks. In the later process, we found out that you can actually input 3 tanks, because in the beginning we also still had a big dispenser, which you may know from your local LNG provider, these huge dispensing stations. We thought about putting them inside the car, but as we found out, they are way too heavy for our car, because we want to stay inside the limitations of the 3.5 tons. So we had to design the dispenser system ourselves, and also get more or less rid of the big drum hose, which also reduced the weight a lot, and also opened more space for the for another tank. And here you also see an air compressor and a cryogenic pump. The air compressor is actually one of the most important part of the system, because the cryogenic pump is operated by compressed air. And also for the fueling process, you most often need compressed air to clean the residual ice of any receptacle or the cryogenic coupling. And also a battery to power the whole system, which is also powered by a solar panel on the top. Yes. Now, we decided on a Crafter VW von Volkswagen, which has a payload of about 1.3 tons, which we found in our research is one of the bigger payloads. And yeah, the 3.5 tons enables us to have the car driven with a standard license, so everyone can drive the car. And the high roof actually also enables us to have a bigger capacity tank of about 450 liters that can be loaded. And we can thus also equip the unloading equipment, also the dispenser, and also the electrical and compressed air equipment on the side or on the walls of the crafter. Inside we have, of course, the tank plus an loading support with a winch, because the tank, although it's mobile, it can be quite heavy to handle with only one person, so we have installed a winch to help the loading and unloading process. And also, of course, the dispensing system with hoses and the quick coupling, the compressor for the compressed air, and a safety system with a gas detector and then a safety shut-off, so the whole electric system can shut down, and the solar modules and an accumulator for the power supply. And of course, you somehow have to measure how much LNG you have loaded or unloaded. There we have designed a weighting system below the actual tank. So we do not use the normal flow meters. We use a weighting system for the actual tank. Here an overview of the car, which you can also see outside later. Here we have installed the tank in the middle with safety belts for safety measurements. It's connected with two hoses, but I come to that later. Here on the right side we have the compressed air compartment, the electrical compartment. Here's the control panel, which controls every part in the car, but I'll also explain it a little bit later. Here you see the standard nozzle for the coupling. And of course on the left side is the dispensing system with a pump and activated fuel cells. Not fuel, valves, sorry. And in the back you see also the ramp and here the winch for the unloading and loading process of the tank, which could also be loaded to the side, but mostly it's to the back. Here is our energy scheme. You see everything is connected to the control panel. We have an inverter to provide power for the compressor from the solar panels, which is also monitored by a solar charge system, and also the battery can be monitored by an app, so that you always know how much is left in the battery. And of course we have some residual current circuit breaker and normal circuit breakers in the energy system, which are located around here. And the gas detector is actually right here. This is a scheme of our dispensing system with the activated valves here, here, and here for the loading process and for the unloading process. We need to activate different valves. We also have a check valve for the loading side, and also some safety valves for the pressure inside the pipes. And also we can load and unload through this part with a diverter valve, so that you don't always have to unload the tank. You can directly load the tank inside the car. And now we come to the control panel, which actually controls the whole car. We have at the top the control for the winch and for the energy. So if you press this switch, and this red switch is the power on and the safety shut off. So you activate the safety shut off, and then you press this button, and then you can use the energy inside the car. The second row is for the activated valves, and the third row is for the winch and a light panel for the inside light. And last is the for the compressor, and in case you have to, in the winter times, you may have to support the battery because you have no sun. So you have to plug some power source into here and press this button to load the battery externally. And of course, you also have to use the grounding nail to ground the whole car during the loading process as a safety measurement. How do you actually operate the tank? or the cryogenic vessel, the tank is situated, as you see, above the weighting system. It's secured with 3 safety belts, and also the wheels itself can also be locked in place to have another safety measurement. And since we have relatively short hoses for the vent connection and the fluid connection, they also provide some kind of stability to position the tank. Here a side view of the tank. You see that the tank is connected through flanges. Now, if you want to operate the compressed gas, as I said in the beginning, you activate the energy system and then press this button to actually start the compressor. And if you want to use the compressed air for measurement, you only need 2 bars inside the tanks. But if you want, for example, clean your couplings, you need around 4 to 5 bars to have enough pressure on the air gun. And for the process itself, you need to power at least up to 8 bar, because because the pump is driven by the compressed air, and to convert the internal pressure of our tank, which is around 4 bars, to the normal pressure of 8 to 10 bars in the consumer tanks, we need at least 8 bar of pressure for the air-driven pump. Yeah, and here you see the liquid hose, the liquid quick coupling and the vent quick coupling for the consumer tanks. They are more or less, this one is directly mounted on the car, and this one is held in place by a rubber, which is actually, it looks funny, but it's actually quite durable. You can try it outside to rip it out. It will be quite hard to rip it actually out. Yeah, and to actually start the process, we need, as I said, these 4 activated valves. The number 1 and number 2 you need for the fueling process. And if you are done with the fueling, you activate number 3 and close 1 and 2. And of course, the pump is valve number 4. And the measurement system, as I said in the beginning, the tank is directly mounted above 4 pads. So you actually move the tank up and down to completely free the tank of any outside influence, and then you measure the weight of the tank and directly know how much liquid you loaded or unloaded. And of course, don't forget, if you are done, to fasten the belts again. Yeah, and for the loading process, as I said in the beginning, we have a winch. And also on the side and on the back, you can control the winch, if in case you are only 1 person. If you are 2 persons, then maybe you don't have the problem, but sometimes it can be quite beneficial to directly stand next to the tank during the loading process or unloading process. So we have 1 on the side and 1 on the back. And of course, the ramps that can be attached to the back and to the side. And they are situated behind the driver cabin. Yeah, and at last, our gas safety system. We have a gas detector that automatically detects gas when the system is turned on. So it only works when the system is turned on. And we also have a hand sensor, which you can use on any connection you want to check the system if it's still airtight. And of course, as was asked for the container, we also have ventilation on the side and on the floor. That's it. Thank you very much, and you can visit the car outside if you have any more questions. We can also go directly to the car.
Any questions? No. Okay, great. Thank you, Kai. And is that immediate then, that we can go and have a look at the vehicle? Thank you very much, Kai.